If Excel freezes the moment you add XLOOKUP or VLOOKUP, it's usually not the lookup itself. It's the way the workbook is being forced to recalculate. The good news is you can fix it without buying a faster computer. In the next few minutes, you'll learn how to spot the real causes, volatile formulas, oversized ranges, and unnecessary full column references. You'll also learn a clean approach to rebuild lookups so they calculate less often and touch less data. Think of it like reducing the number of times Excel has to recheck the entire room just to find one item. We'll start with a quick mental model of what recalc lag really means. Then we'll go through the most common patterns that trigger it. Finally, you'll get a practical checklist you can apply to any slow file. The goal is simple. Keep your formulas accurate, but stop Excel from doing extra work. Next step. To fix freezing, you need one concept. Excel recalculates in a dependency chain. A cell changes, then any formula that depends on it recalculates. Then anything depending on those results recalculates. And the chain is huge, you feel it as lag or a temporary freeze. XLOOKUP and VLOOKUP often sit in the middle of big chains because they feed many downstream formulas. Another key detail is calculation mode. In automatic mode, Excel recalculates whenever it thinks it should. In manual mode, it waits until you tell it to calculate. Manual mode can be a lifesaver for diagnosis, but it can also hide problems until you hit recalc and everything stalls. The real target is reducing how much work each recalculation requires. That means fewer formulas recalculating and less data scanned per formula. Once you think in those terms, the fixes become straightforward and repeatable. Next step. The fastest way to identify the culprit is to separate lookup cost from recalc frequency. A lookup can be expensive because it scans a large range, or it can be cheap, but forced to run thousands of times because something volatile keeps changing. Start by asking two questions. First, how many lookup formulas exist? Hundreds, thousands, or tens of thousands? Second, what size ranges do they search? If each lookup scans 1,000,000 rows, even a few hundred formulas can hurt. If each lookup scans a small table but recalculates constantly, that's a volatility problem. Also watch for workbook-wide triggers like links to other workbooks, dynamic arrays spilling into large areas, or formulas that reference entire columns. Your goal in this step is not to fix anything yet. It's to classify the slowdown, range size problem, frequency problem, or both. Next step. Volatile functions are the most common reason a workbook feels like it's thinking after every small edit. A volatile function recalculates whenever Excel recalculates, even if its inputs didn't change. Classic examples are today, now, rand between, offset, and indirect. If your lookup depends on a volatile function, directly or indirectly, it can be forced to recalc far more than you expect. For example, using indirect to build a lookup range from text feels flexible, but it prevents Excel from tracking dependencies efficiently. Offset is similar. It creates dynamic ranges, but it's volatile and can trigger broad recalculation. The fix is usually to replace volatile building blocks with non-volatile alternatives. Use structured references in tables, use index instead of offset, and avoid indirect unless there is no other option. This one change often turns freezing into instant. Next step. Let's talk about the most expensive lookup pattern, full column references. Using something like A:(A) or 1:1 feels convenient, but it quietly tells Excel to consider over 1,000,000 rows. With VLOOKUP, that means scanning a huge range. With XLOOKUP, it still means handling a massive array, even if the match is near the top. Multiply that by thousands of formulas, and you get long recalculation pauses. The fix is simple, but requires discipline. Use bounded ranges that reflect your real data. Better yet, convert your data to an Excel table and reference the table columns. Tables automatically expand as data grows, so you keep flexibility without paying the full column penalty. If you can't use tables, define dynamic named ranges that grow with data, but avoid volatile methods like offset. The key idea is to stop asking Excel to search empty space. Next step. Next is match mode and search behavior. With VLOOKUP, many people use approximate match without realizing it, or they use exact match on unsorted data and pay for slower scans. With XLOOKUP, you can control match mode and search mode. Exact match is usually safest, but search mode matters when datasets are large. If you know the data is sorted, a binary search can be faster, but only when sorting is reliable and consistent. If sorting can't be trusted, stick with exact match and focus on reducing range size. Another performance lever is choosing the right key. Text keys with extra spaces, inconsistent casing, or mixed types cause extra work and errors. Clean keys once, then look up on clean keys. Also consider using helper columns for composite keys instead of concatenating inside every lookup. That reduces repeated computation and stabilizes results. Next step. A big hidden cost is repeating the same lookup over and over. You'll see this when one row contains multiple formulas that all look up the same ID, just to return different columns. That means Excel performs the same match repeatedly. A cleaner approach is to do the match once, then reuse it. One method is to use XLOOKUP to return multiple columns at once, if your version supports dynamic arrays and your layout allows it. Another method is to use match to find the row position once. Store that result in a helper column, then use index to retrieve different fields. This can cut calculation time dramatically because match is done once per row, not 5 times per row. The trade-off is slightly more structure in your sheet, but that structure is exactly what keeps large models responsive. Next step. Another common freeze trigger is error handling wrapped around heavy formulas. IFERROR looks harmless, but it forces Excel to evaluate the formula to see if it errors. If you wrap a huge lookup in IFERROR across thousands of rows, you still pay the lookup cost. Sometimes you even pay extra because errors cause additional work. A better pattern is to prevent the error earlier. For example, test whether the lookup value is blank before running the lookup, or validate that the key exists using a lightweight check. With XLOOKUP, you can use the built-in if-not-found argument instead of IFERROR, which is often cleaner and can reduce unnecessary branching. The goal is to avoid running expensive formulas when inputs are empty, incomplete, or obviously invalid. This is especially important in templates where many rows are unused most of the time. Next step. Now let's cover spill ranges and dynamic arrays. Dynamic arrays are powerful, but they can create large calculation footprints. If a single XLOOKUP spills thousands of results, every dependent formula now depends on that entire spill range. That can amplify recalculation. The fix is to be intentional about where you spill and how much you spill. Keep spill ranges bounded. Avoid referencing entire spill ranges when you only need a small part. If you're using filter, sort, or unique to build lookup sources, make sure those sources are not recalculating unnecessarily due to volatility or oversized inputs. Also, watch for circular patterns where a spill output feeds back into a table that feeds the spill. That can create repeated recalculation attempts. Dynamic arrays are not slow by default. They're slow when they expand too far or when they sit on top of unstable inputs. Next step. Sometimes the workbook freezes because calculation is competing with other heavy features. Conditional formatting across huge ranges can force Excel to reevaluate formats constantly. Data validation lists that reference volatile formulas can also trigger extra recalculation. Pivot tables connected to the same data can refresh and recalc at awkward times. Even external links can cause delays when Excel checks for updates. The key is to isolate. Temporarily reduce conditional formatting ranges to the used area. Avoid applying formatting rules to entire columns. Keep validation lists in small, stable ranges. If you use Power Query or pivot tables, separate refresh steps from calculation steps, so you're not doing everything at once. You're not removing features. You're reducing how often they demand attention from the calculation engine. This is how you turn a fragile workbook into a stable one. Next step. When you need a reliable diagnostic step, switch to manual calculation temporarily and control when recalculation happens. The purpose is to stop Excel from recalculating after every tiny edit while you're investigating. Then make one change at a time and trigger a full calculation. If the lag disappears after removing a volatile function, you've found a major driver. If the lag improves after bounding ranges, you've confirmed a range size issue. Also consider breaking the workbook into stages. For example, compute lookup results once in a dedicated sheet, then reference those results elsewhere. That reduces repeated recalculation across many sheets. Another practical tactic is to convert some results to values when they no longer need to be live. That's not always appropriate, but for historical periods or closed months, it can be a huge performance win. The theme is control. Fewer surprise recalcs. Next step, if you want a robust long-term fix, build a lookup architecture that scales. First, store source data in tables, not loose ranges. Second, standardize keys, same data type, trimmed text, consistent format. Third, avoid volatile range construction. Fourth, compute matches once and reuse them. Fifth, keep downstream formulas simple so they don't multiply the cost of every lookup. If your dataset is truly large, consider whether Excel formulas should do the retrieval at all. Sometimes Power Query is better for merging tables once than loading a clean result set. That shifts work from constant recalculation to an intentional refresh step. The trade-off is that results are not instantly live after each edit, but performance and stability often improve dramatically. The right approach depends on whether you need live recalculation or periodic refresh. Next step. Here's a practical checklist you can run through whenever Excel freezes around lookups. 1. Search for volatile functions like indirect and offset. 2. Replace full column references with bounded ranges or tables. 3. Reduce repeated lookups by reusing a single match result. 4. Stop running lookups on blank rows by adding simple input checks. 5. Shrink conditional formatting and validation ranges to the used area. 6. Test in manual calculation mode to confirm what change actually helped. The key is to treat performance like debugging, not like guessing. Make one change, test, and keep the change only if it improves responsiveness. If you do this consistently, you'll end up with workbooks that feel fast even when they're complex. And you'll trust your models more because they're less likely to hang at the worst possible moment. Next step. To wrap this up, Excel freezing with XLOOKUP or VLOOKUP is usually a symptom of recalculation overload. Your biggest wins come from reducing volatility, shrinking search ranges, and avoiding repeated work. If you implement just 2 habits, using tables instead of full columns and replacing volatile range tricks, you'll feel a difference immediately in most files. Then, as your models grow, reuse matches and keep downstream formulas simple. If you want, I can also share a template-style pattern for match once, return many fields that stays fast at scale. For now, I'd like to hear what's causing the pain in your file. Comment with your experience. Do you freeze more from volatile functions or from huge ranges, A or B? And if you want more Excel performance deep dives like this, subscribe. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.